All right. So get started here. So before we get going, one thing I wanted to mention is so I had that module 8 reading. It was under the assignments tab. But when I put it to the home page, it was under a heading that wasn't published. So even though it looked like it was published to me, I don't think you could see it on the home page. A lot of you found it already, and I mentioned it in class, so I'm sure you looked for it or just went to Top Hat, and you could still access the assignment. But just out of fairness, because it wasn't popping up on the home page, I kind of pushed that due date, and I put an announcement up yesterday when I realized it. Um, if you haven't completed it, which you should have completed by the end of the day today, but if there was some confusion about not seeing it on the home page, but you know what? Once again, it was under the assignments tab or on Top Hat. I kind of put that due date to be the end of the day today. Okay. So usually these are kind of, I was talking with a student yesterday, stopped by during office hours. They're probably the most effective to kind of look at the material before we cover it in class, which is why I have them assigned before we kind of cover the material in class. But for this one, because of that kind of publishing error on Canvas, if you haven't completed it, you have till the end of the day to complete it. Okay. Other than that, I don't think there's any other housekeeping stuff, just kind of where we're going. We've got module 8 this week, which will start to look a little bit like module 2, but we're going to have this in a different context, which is not the firms or producers or economies we're thinking about in terms of consumers. Okay. And then next week, we'll talk about firms' costs when we have spring break. And then when we come back, we'll have a review class on that Tuesday, and then the exam will be that Thursday. Okay. So I'll talk more about that next week, but that's kind of our roadmap. Okay. Any questions for me before we dive into material here? Okay. All right. So we're looking at module 8, right? And I'll try to connect this to things we've already talked about, but we are going to be thinking just in the mindset of consumers this week. Okay. So we're thinking about when you go to buy something, and we'll kind of simplify this to 2 goods when we start out. You have all of this income you can spend. So we'll start representing income with this kind of letter M, right? So I've got all this income and I can buy 2 goods. How much can I buy? Well, however, I'm spending all of my money, then however many units of X I'm buying times the price of X, that would kind of represent like the total amount of money I'm spending on X. And if I add to that the quantity of Y I'm buying times the price of Y, that's like the total amount of money I'm spending on this Y good. If I add those together, if we're spending all of our money, that's how much we could spend. Now I can buy different combinations of X and Y, and they might still add up to the same income. So if I go to the store, I don't know, I could buy 5 sweatshirts and 3 pairs of pants. Maybe I could afford that. I could also afford 5 pairs of pants and 2 sweatshirts, right? Depending on kind of their price. And that's thinking about when we're spending all of our income. Okay. Now, I'll kind of talk about, you might be already thinking about, well, what if I save money? We can model that along the way. We'll kind of talk about that a little bit later on. But for right now, let's assume we're spending all of our income, okay? Just on 2 goods to make it simple, right? So what we would call this is kind of our budget line, right? We can spend up to whatever our income is. Kind of similar to what we talked about before with economies. They can produce goods up to using all of their resources. Here, income is a consumer's resource, right? So if I'm using all of my resources, spending money on these 2 goods, here's the total amount I have to spend. Okay. So let's kind of use these hypothetical incomes and prices, right? Then I would have my kind of budget line where I plug in the price of the X good, plug in the price of the Y good, and I can think about M here. Starting out, we have $40 to spend. Okay. So what's going to end up being true is if I have income, and I'm buying, let's say I'm only buying X. So in my example, I'm only buying sweatshirts. Spending all my income and I want to buy a pair of pants, what do I have to do? I don't have any money left, so what do I have to do? Stop buying sweatshirts, right? Stop buying a few sweatshirts and switch over instead to buying pants or whatever the 2 goods are. So there's kind of this trade-off, right? If I want more of the X good, I have to give up some of the Y. What does that sound similar to? An opportunity cost, right? So we're kind of reusing these concepts as we kind of progress throughout the semester. So I think I had here 2 different examples, right? Pizza and Pepsi if I'm going out to eat. If I want to buy that first drink, I'm going to have to give up some pizza that I'm buying in order to afford it. Okay. So if we think about when we're looking at this budget line, right? It's going to be very similar to the production possibilities curve. So I'll kind of jump ahead a little bit here. And we can think about using these values. So get the light looking a little better. There we go. So what we're really thinking about visually is I can buy this X good and I can buy this Y good. If my total income is $40, the price of, let me make sure I'm lining this up with the slides just so there's no confusion, because I already forgot what the price of, so X was 2. Okay. So the price of X is, say, $2, and the price of my Y good was 5, right? If I'm only buying that X good, how much can I afford? If I've got $40, each unit costs 2, I could buy whatever my income is divided by that price, right? I have $40, costs $2, I can buy a total of what? 20. Now, if I'm only buying the Y good, how much can I afford? Well, whatever my income is divided by the price of good Y, or 40 over 5 would give me what? 8 here. Right? So we think about if I'm only buying good Y and I want to start to buy good X, right? As I start to buy X, if I'm spending all my income, right? That's how I kind of found these two extreme points. I was spending all my income on good. If I want more X, I'm going to have to start that. I'm going to have to stop buying some of good Y, right? So we have this negative slope for our budget constraint, right? And that kind of reflects this trade-off between if I want more of one good, I have to stop buying some of the other, okay? What does this look similar to? An individual PPC, right? Or production possibilities curve. You can almost think about now it's like the consumer's consumption curve, right? I guess CCC is kind of a weird thing, but that's kind of how we can think about it, right? So if I wanted to find the slope and I had these two extreme points, how would I do that? Well, anytime I want the slope, I'm looking at a graph, it's what? The change in Y over the change in X, right? So if I have those quantities, it's as simple as looking at the change between these 2 points, right? Which would give me what? The quantity, change in quantity of Y, which would be 8 to 0. Change in X, I was going from 0 to 20. So I'd have what? Negative 0.4 if I'm doing math in my head correct here. Okay. So any point that's on this curve would represent what? I'm spending, here maybe you can kind of help think about it. If I'm at these points, that represented when I was spending all of my income on X. This point represents when I'm spending all of my income on Y. Any point in between that's on this income or this budget constraint is going to be points that we can afford. So I could even kind of think about, let's do an easier one. Let's say I wanted to get 5 of that X good. Okay. If I want 5 of that X good, how much total is that going to cost me? If I want 5 units, each one is going to cost me $2. I'd be spending $10 on that X good. So if I'm spending $10 on that X good, how much of the Y good am I going to have to give up? If I'm spending $5 on each unit of Y, if I need $10, how many units of good Y do I have to stop buying? If I need $10 and each unit of Y is $5, how many do I have to stop buying? 2. So I'd be having to go from 8 to 6, right? So when you think about there's this trade-off. When I want to buy more of good X, I have to stop buying some of good Y. And you can already start to envision, we haven't gotten there yet, but it's going to be something about the relative prices of those two goods. So any point on my curve is going to be a point that we say is affordable, right? Or I'm spending all of my income. If I was at any point down here, what am I doing? Well, these are all points where I'm spending all of my income. These will be points where I'm not spending all of my income, right? So they would be affordable, but they're not efficient. I'm not using all of my resources, similar to what we talked about with the production possibilities curve. And then any point up here would be points that what? Yeah, I don't have enough income, or they are unaffordable. So any point on the curve would be affordable, and I'm using all of my income. Any point below the curve, yes, they're still affordable, but I'm not spending or I'm not using all of my income. So it's kind of like the same three ranges we have with the production possibility curve. It's just now it's in terms of consumption. Okay. Any questions on this before we keep moving? So I think in the slides, right, to kind of keep running with this, I have a slightly different example, but I think drawing it out will help, and then we can kind of go through the slides and maybe get kind of a refresher of it, okay? So let's say I'm trying to reinvent my image, right? Let me make sure what I said in the slide. I think I told you, yeah. So we'll put, I'm buying flannel shirts and cans of PBR. I've got $200 to spend. The price of a flannel shirt is 20. Price of that Y good or PBR is, what did I have? 5. Okay. So how would I construct my budget constraint or my budget line? Well, if I was writing this out, we said it was when I'm spending all of my income, it's the price of my Y good times the quantity of that Y good I'm buying plus the quantity, or sorry, price of my X good times the quantity of the X good that I'm buying. Okay. Now I could plug in my prices and plug in my income, right? But if I think about what are these extreme points? So if I'm only buying flannel shirts, before, how did we say I can calculate the total amount I can buy? Well, if I have $200 to spend, each flannel shirt is $20, how many total can I buy? 10, or what did you do there? You took income and you divided it by the price of that good, right? So 200 over 20 gave us that value of 10. If I'm only buying this Y good, PBR, I've got income over the price of that good, which is what? 200 over 5, or I'm at 40. Okay. So if I just find those quantities, what is the slope of my budget constraint? Well, the Y is changing by going from 40 to 0, so negative 40. X is going from 0 to 10. I would have a slope of negative 4. Now let's just go out on a limb, and if we remember what we talked about in module 2, what does the slope tell you? The cost of your x-axis good. So here, the cost is going to be for every additional unit I want of the x-axis good, how much of the y good I'm going to have to give up. Now, we can kind of think about this, right? If I want to buy a flannel shirt and it's $20, how many cans of PBR do I have to give up? 4, right? Each one is 5. I'd have to give up 4. So really, what is this slope? It's going to be the price of my X good, right, over the price of my Y good. Or in our example, the price of a flannel shirt over the price of a can of PBR, right? $20 over 5 gave me that same slope of negative 4. So our cost of the x-axis good will always be that relative price. Now, if you think about Y, so if I wanted the change in the quantity of Y over the change in the quantity of X, that's originally how we were finding the slope. How do I find these two extreme points? Well, the quantity of Y we can buy was what? Our income over the price of that Y good. If we wanted to find how much of X we could buy, it was our income over the price of the X good. If I do a little bit of algebra here, the numerators cancel. If I have 1 over price of Y divided by 1 over the price of X, if I do my algebra here, that just ends up with being the price of X over the price of Y, which is what we set up here, right? So I can think about the cost of my x-axis good will always be the relative price of good X compared to good Y. Now, this seems counterintuitive, right? Because when I calculate a slope using quantities, it's kind of how we typically think about in math. It's the change in the quantity of Y, because that's what's on our Y-axis, divided by the change in the quantity of good X, because that's what's on our X-axis. But remember, these are representing quantities, not the prices. But to find those quantities, the prices kind of exist behind the scenes. So when we do the algebra, it gets flipped. If we're using prices to determine that slope, it's the price of the X good over the price of the Y good. Okay. So if we're using quantities, looks just like how we would find every other kind of slope on a graph. But when we're using those prices, because those prices are kind of behind the scenes, it ends up being counterintuitive and those get flipped. But here's the algebra to prove that that's why it is what it is. Okay. Any questions on this before we keep moving? Now, in our example, what was our X good? Price of a flannel shirt. What was our Y good? So we look at the price of a can of PBR. Sure enough, what did we have? What are my prices? There we go. 20 over 5 gives me that same slope of 4. Now, it's in absolute terms, right? Technically, I should have a negative sign out front here, right? But just like with the production possibilities curve, we know that slope is always negative because of this trade-off. We're just really interested in the absolute value, right? Any questions here before we keep moving? We'll complicate this a little bit in a second. Okay. All right. Okay. So this is basically everything that we just did. But let's now start to think about which of these points would we consider affordable or not affordable. Now, if I'm just looking, I'm telling you these values, which point would be unaffordable? C, the point above my budget constraint. What point is affordable, but I'm not using all of my resources? A, what point is affordable and I'm using all of my resources or spending all of my money? Any point on my budget constraint or any point on this line. So that would be a B. Now we could prove this to ourselves by thinking about, okay, if point B was 8 and 8, right? Why is that point on my curve? So I'll kind of, try to get rid of some stuff here so that's a little bit cleaner to look at. But we had this example before where we were thinking about flannel shirts, we had PBR, and we had our two kind of intercepts were 40 and 10. Thank you. I didn't hit it hard enough. There we go. All right, so we're just kind of starting out clean slate, right? That point of B, we were saying was 8 and 8. How can we check to see if that is actually on our curve, right? Well, there's a couple different ways. But if I was at 8 for the quantity of the X good, what point would be on that curve? Excuse me. Well, we already found using either those relative prices or the changes in the quantities, right? We had that this was going to be -4. So if I wanted 8 more of that X-axis good, it's going to cost me 4 units of good Y. So if I want to get 8 of the X good, how many of the Y good am I going to have to give up? Well, if each unit costs me 4, the total amount I have to give up would be 32. So I'd be going from 40 to what value? 40 minus 32 would be 8. You can think about it in a different way. If I have $200 to spend, all right, that was my income. If I want to get 8 of that X-axis good, we had kind of the price of a flannel shirt was 20, price of a can of PBR was 5. So if I want 8 flannel shirts, how much total is that going to cost me? The price of a flannel shirt times, well, we wanted 8 of them, right? So that would be what? The price is 20, so $160. If I need $160 to buy these 8 shirts, how many cans of PBR am I going to have to give up? Well, if each one costs 5, I'd have to take that $160 that I need, divide it by the price of that other good, and that would give me, oh, I need to give up 32 of that. So it's another way of thinking about it. But it's really just like when we were finding, once we know the slope, we know the cost of that X-axis good, it's just like finding points in our production possibilities curve, okay? It's just now we don't have this bowed out shape. It's a simple individual production possibilities curve, which is now our individual consumption curve, All right, we're thinking about consumers buying these two goods with their income. Okay. Any questions here before we keep moving? Yeah. Huh? A decimal? Then it would just, that's what it ends up being, right? So you'd have to give up half a unit, right? Now, in reality, right, you have to give up one unit or another. So it wouldn't be as nice and continuous as this, right? You would actually have like steps. I'm not going to make it more complicated for you, have you do that. You would just have to say, what's the exact value? If it ends up being half of a shirt, that is what it is, right? That would be kind of our solution, right? Now, in the problems I give you, I'll try to keep things so where the answers are nice kind of integer values so they make a little more sense in the real world context. Okay. Any other questions before we keep moving? Okay. So let me see here. I think I might want to stay here for a second. Yeah. So, well, we'll look at the slides and maybe I'll give you a little bit more intuition as to why. We'll come back and draw it out here in a second. So we just kind of checked that point B. We could do a similar thing to check points A and C. And what we would end up seeing is that those points aren't on our budget constraint, right? They aren't kind of using all of our resources. They're either unaffordable or we're not using all of our income. Okay? Now, what happens to our budget constraint if we have a change in income? So the easiest way to think about this, first of all, what did we say is going to be the slope of our budget constraint? The relative. So we can look at quantities, but we can also look at prices. Have the prices changed? No. So our slope is going to stay the exact same if we have an income change, because our slope is always those relative prices. Now, how did we find those two intercepts? We took our income and we divided by the price of that good. So what's going to happen to both of our intercept values? Well, if I'm only buying good X, I now have more money. I can buy more. So what's going to happen to my intercepts? They're going to increase. But if the slope is the same, then really we're getting these nice parallel shifts when income changes. Now I'm talking about an income increase. What happens if I have an income decrease? Then my budget constraint is going to shift down, right? Parallel shifts, but then it can now afford to buy less of both goods, okay? Now, what if I have a price change? That's just a little bit trickier to think about. So we'll kind of first think about, here was our original budget constraint. This is the example we've been running with. What if my income goes up by goes up to 300, right? Goes up by $100. Well, if I'm spending all of my money on flannel shirts, I can now buy a total not of 10, but how many? I have $300, price is 20, divide 300 by 20, I get 15. If I'm spending all of my income on PBR, $300 divided by that same old price of 5, I can now buy 60. So with income changes, we get this nice parallel shift. Now the slope doesn't change. I said you can think about why. It's because the prices haven't changed. But even if we want to convince ourselves that it's not just the prices, we can also use quantities. From my new intercept values of 60 and 15, what's the change in the quantity of Y? It's going from 60 to 0. What's the change in the quantity of X? It's going from 0 to 15. 60 over 15 gives me the slope of 4. Right? It's the exact same as what it was before. 40 over 10 was also 4, or I should say negative 4, right? I'm talking in absolute terms. So the opportunity cost of the x-axis good doesn't change when we have income changes. It just shifts that budget constraint out. Think about it this way. Every point in between these two curves, it used to be points that were what? Well, if it was above my old budget constraint, they were points that were unattainable, or now we use the word of consumers, unaffordable. But same idea. Now, every point in this range, I can afford. In fact, not only can I afford it, all the points in the middle here, I actually would not be using all of my income. So these income kind of changes just shift our budget constraint. Now, what if we have a change in the price of flannel shirts, right? So just intuitively, if the price goes down, can I afford to buy more or less than I was before of flannel shirts? more, right? Now, if I have combinations of these two goods and the price of one goes down, there's not only can I buy more flannel shirts if I'm only buying flannel shirts, I can afford different combinations of these two goods that I couldn't afford before. So if we think about if I'm only buying PBR and the price of flannel shirts goes down, if I'm only buying PBR, how much total can I buy? The exact same amount, right? So my intercept for that good that did not experience the price change will remain the same. However, the good that experienced that price change, if it's a lower price, I can now afford to buy more, right? So now if instead I've got $200 and the price is only 10, I can now, instead of buying 10 flannel shirts, I can now buy 20. So I can find these intercept values. Now, when I have a change in the price of a good, what was the slope? It was the relative prices. So if one of those prices change, our slope's going to change. Now we can prove this to ourselves. It should be that the slope is the relative price of X to the price of good Y. So for us, the price of the X good, right, was now 10. The price of the Y good, remember from the last slide, was 5. So it should be, what, 10 over 5 or 2. And it's always negative, so negative 2. Now, if we don't use the prices, right, let's convince ourselves of this using the quantities. So now when I'm calculating the slope of this budget constraint, what's the change in the quantity of good Y? It's going from 40 to 0, so 40. Now the change in my X good is going from 0 to 20. 40 over 20 would be, sure enough, negative 2. Right? So we can use the quantities, or we can just simply remember that slope is the relative price of good X compared to the price of good Y, or the fraction of the price of good X over the price of good Y. Okay. Any questions on that idea before we keep moving? So this looks kind of similar to what when we looked at module 2. What changed the slope of our production possibilities curve when we had a technology improvement and just only one good? Similar idea here. What kind of changes the slope of our consumption curve or our budget line? Well, it's not technology. That changed how costly it was to produce something. Here, how costly is it to consume something? That's the price, right? So changes in a price of one good would kind of give us this change in the slope of our consumption curve or our budget line, okay? All right, so I'm going to go through one other thought experiment here, and then we'll kind of get somewhere where I want to be, okay? So let's say I had that same example. So we keep on running with the same thing, but I want to do something a little bit different here, okay? So we started out originally, I had $200 to spend. Flannel shirts were 20, cans of PBR were $5, okay? And then just as a reminder, that slope was the price of X over the price of Y. So our X good was flannel shirts. Our Y good was PBR. We had a slope of negative 4. Right? Let's now instead assume that the price of a can of PBR goes up. So before we had flannel shirts, the price was going down. So this is where on any question on the quiz and the exam, I can change price increase to price decrease. I could change it from a price increase in X to a price increase in Y, etc. So let's say the price of a can of PBR now goes up, just to kind of keep the numbers nice and easy, to $10, which is ridiculous, but let's say it happened, right? If I was just using my relative prices, I don't have to really draw anything out here, because what would the slope of my new production possibilities curve be? I said production possibilities. What would the new slope of my budget constraint be? Well, the X good I had was flannel shirts. The Y good I had was PBR. It should be now what? 20 over 10 or negative 2, right? An absolute value 2. Yeah. Now, I could use the quantities. I'm like, I think this was right. I think it was X over Y because it's not intuitive. It's counterintuitive. But let me check this with the quantities. So if the price of PBR is now $10, if I'm only buying flannel shirts, how many can I afford to buy? Well, my income didn't change. Price of flannel shirt didn't change. So if I'm only buying flannel shirts, I can buy the exact same amount. Now, if I'm only buying cans of PBR, how many total can I afford to buy? We said that was the price, sorry, the income over the price of that good. So if I had $200, the new price is 10. Instead of being able to buy 40, I can now only buy 20. So my new budget constraint, or my budget line, will be down here. Its slope, notice, is what? Flatter. So it should be a lower value than before. In fact, we said already, oh yeah, it is a lower value than before, right? It's not -4, it's -2, or lower in absolute terms. Now, if I use the quantities, it's the change in my Y good over the change in my X good. Sure enough, what do I find? It was going from 20 to 0, 0 to 10. I get that same slope as if I use the relative prices. So changes in the price of one good would kind of change the slope of our budget or income constraint, but we still have kind of a similar idea. All these points here, with the old prices, we would say those points were what? They were affordable, but we weren't using all of our income. They weren't efficient or consumption efficient, right? We're just thinking about consumers here. With our new budget constraint, all of these points here would now be what? Well, if they're above my budget line, they are now unaffordable. Okay. So, and this intuitively makes sense. When prices go up, there's going to be certain combinations of these two goods that I used to be able to afford that I no longer can. When the prices went down, there were points that we used to not be able to afford that we now are able to given the lower prices. So that result is kind of intuitive, right? When prices go up, there's points that we no longer can afford. When prices go down, there are now points that I used to not be able to afford that I now can. Okay. Any change or any questions here before we keep moving? Okay. We'll see where we're at. If we have time, I might mention something else that might help also think about this. So let's say I had something like this, right? Let's just think through this, and I might ask you a few questions. So what would, going from the original black line to the green line, what had to happen? Well, if I, on my new budget constraint, only buying good X, I can afford the same amount. But if I'm buying good Y, I can afford to buy more. What must have happened? There was a change in the price of good Y. Not only do I know there was a change, if I can afford to buy more, the price must have went down. Now, what about going from the original black line to the blue line? Well, if I'm only buying Y, I can afford to buy the same amount. If I can buy B, I can now buy more. So what must have happened? The price of the, oh, sorry, I'm only buying B's. If I'm only buying the X good and I'm on this kind of new curve B, it must be that what? The price of the X good changed. And if I can buy more of it, the price must have went down. What would lines A represent, right? So going from the black line to the red line. If it's a parallel shift, you said that was an increase in income. What if I had a decrease in income? That would actually be if my line shifted down. Now, here's kind of a tricky question. What could also, let's say my income stayed the same. How could I actually move from the black line to the red line? Well, if I can afford to buy more of good X, if I'm only buying X, if my income didn't change, what had to happen? The price of X went down. If I'm only buying Y, my income didn't change, but I can afford to buy more, what must have happened? Price of Y has went down. So if I have simultaneous changes in prices, I could see a parallel shift in my income constraint or my budget line. Now, what would have to be true about the changes in those prices? The slope's the same, they would both have to change by not the same dollar amount, but kind of the same percentage change or the same proportional change, right? So maybe before the prices were 10 and 5, if now they're 5 and 2.5, I can buy more of both goods, but that relative price hasn't changed. So these are all possibilities. We're now going to look at I believe I've got this set correct. So we'll make sure. I thought I knew where I'd be at in time. So let's say we'll go to 8:42. I'm going to double check in the code here today. I think I forgot this one. So 38.15 is what will kind of get you into. So 38.15, and I'm going to come down here so that you can see it on the home page. I'm going to publish it. Okay. So 38.15 will get you in. We've got till 8:42. I'm not going to work through this one with you guys today. I think based off of what we've discussed, this shouldn't be too bad. Okay. So talk to the people around you, work through these next 3 questions if I can get it to load. But basically you have 2 goods, coffee and tea, right? I need to get my caffeine from somewhere. So if I started out here, I give you someone spending all of their income. What must the price of tea be? Knowing those kind of intercept values, you can figure that out, right? Then you have kind of a similar thing. If you know the price of tea and you know the quantity, right, of both of these goods, what must the price of the other good be? And then kind of similar to what we just went through, what must be true relative to the black line that would give you these kind of additional. Now, we literally just talked through this one, so hopefully this one shouldn't be too bad. So I'll give you about the next, I had it to 42, so 6 minutes, work with the people around you. I'll give you a prompt to make sure you get it submitted before time. But I'll give you a little bit of time to work on this, work through it, okay? Everybody in okay? We're all good? Okay, like I said, you don't have to be quiet. Talk to people around you, try to figure this out. All right, so start wrapping up here in the next minute or so. Got 8:42 to kind of get this submitted. All right, so make sure you're hitting the submit button. I have it set to be due at 8:42. So as long as you're kind of hitting that right now at 8:42, it'll be kind of accepted. So we'll kind of talk through some of these together. But hit submit now because our discussion will go past that due date, okay? Or due time, I should say. So let's look at the last one first, because hopefully this should have been relatively easy based off what we talked about, right? So if I'm thinking about line A, if I had an increase, so the black line was kind of our reference. What did we say is the only way we see us move to this budget constraint or this budget line A? If we had an increase in income, or we saw that the price of both goods went down. If I can afford to buy more of both goods when I'm only buying them, it must be that they simultaneously had a price decrease. So both of them having a price increase would actually do what? Wouldn't shift our curve out, but would actually shift it down. Right? We said price decreases in both goods to get us to line A. So we can rule that one out. Point or line B represents an increase in the price of good X. If our budget constraint is ever moving outward, that means that we either have an increase in income, or given the same income prices must be. What's the only way that points that used to be unaffordable are now affordable? If prices go down. So the only way I can get to line C or B or A is if I have price decreases. So right away, the only one that makes sense here is if I had a decrease in the price of good Y, I can get to line C, right? All of the other three things would only cause our budget constraint, our income line to go down. And we kind of talked through this before I gave you this question. So if you're paying attention, hopefully that one wasn't too bad. Now, the other two were a little bit different than how we talked about things. So let's start out. I have this graph where I've got the quantity of tea on my y-axis, it's 50, quantity of coffee or my X good is 80. Okay. I'm then telling you, okay, you have $200 to spend. What's the price of tea here? Well, if I drew this out, right, how would I find that quantity of tea? If I'm only buying tea, how do I find how much I can afford to buy? I would take my income and divide it by the price of that good. So if I have kind of income is 200 and the quantity I can afford to buy is 50, it's really just plugging that in, right? So we said income over the price of tea would tell us if we're only buying tea, the amount we can afford to buy. Well, I know the quantity is 50. I don't know the price, but I was told my income is 200. Now it's a little bit of algebra, right? So I multiply both sides by the price of tea. divide both sides by 50, and I get that the price of T must be equal to 4. Okay. Any questions on that idea before we keep moving? Okay. Now, the other one, I believe I changed the values. So I think I was at 40 and 100. So if I have the quantities, how can I find the slope of this line? Simply the change in the quantity of the Y good over the change in the quantity. So here I have what? 40 over 100 in absolute terms. So technically it's negative. So like what? Negative 0.4. But I also know the slope is equal to what? The relative price of good X to the price of good Y. Now, I think in this problem, I told you the price of one of the goods. Which one was it? I had the price of T is $2, right? So here, what's on my x-axis? Coffee. So the price of coffee over the price of T. If the price of T is $2, now it's just a little bit of algebra. Multiply both sides by 2 to find that the price of coffee must have been 0.8 or 80 cents. Okay. So using what we know about the slope, using what we know about how we find these kind of two intercept values, I can always give you 2 of those and you can solve for the third, right? It'll always just be kind of basic algebra. Okay. Any questions over any one of those problems here? Okay with this? Okay. All right. So if we're good with that, all right, we'll start talking about the next concept here, right? And this will kind of bleed over into next class. But we've got this budget constraint, right? Thinking about the different combinations of 2 goods we can afford to buy, okay? So the next thing that we want to do is think about, okay, just because I can have, I don't know, 8 slices of pizza, but no cans of Pepsi, that might not be optimal when I sit down to eat, as opposed to having 6 slices of pizza, but having also a drink, right? So even though I can afford those different combinations of the 2 goods, which one would provide me the highest level of happiness, or what we'll start calling consumers' happiness is this word of utility, right? How much happiness or how much does this combination of these 2 goods bring me? Now, in reality, it's not just 2 goods, it's, thousands, right? And so if I'm thinking about, what brings me higher levels of utility, well, if I have 1 house, but no cars, 0 apartments, maybe it's better to have an apartment and a car instead of owning my own house, right? So there's these different combinations of these goods, and some of them might provide me higher or lower levels of utility or happiness, okay? So what we're going to end up looking at eventually is what we call a utility function, right? It kind of tells me what is the happiness that I gain by owning this combination of these 2 goods. Now, in reality, it's more than 2. We're going to keep everything simplified just looking at 2 good models, okay? The math just becomes more complicated if we add in more possible goods we can buy. So we'll start making this differentiation between marginal and totals. We've done this before, and it matters, right? So if I think about total utility, it's the total utility I'm getting across every good that I buy, right? Or the total level of happiness I'm getting from the amount of both X and Y that I'm currently buying. Now, marginal utility, anytime we see this word marginal, we should be thinking about the change, right? So marginal utility would be, okay, what's the change in the total utility I'm getting from good X divided by, well, how many more units of good X did I have to buy to get that utility? So the marginal utility I get from good X is the change in the total utility divided by the change in the quantity or the number of units I'm buying. So just go out on a limb here. What do you think happens to total utility as you buy more of any good? So if I'm buying more and more watches, my total utility is going up, right? Now, what's happening though? As I go from 0 to 1, that first watch I buy is going to be the one that I really, really liked, right? So what's the margin utility of the first watch going to be? Pretty high. Now, as I buy more and more watches, what am I selecting? Ones that I didn't like quite as much, okay? So as I buy more, or maybe having 1 watch, I can only wear 1 at a time. So the change in total utility, it'll still be increasing, but as I buy the second watch, the margin utility, it's not going to be as high as the first. This is the idea of cars also. If I buy a car, that first car I own, huge margin utility to my life. But if I have two, I can only drive one at a time. Maybe the other one's kind of a fun, old Jeep or something I can drive on the weekends, but it doesn't give me near as much utility as that first one. So we have kind of a very similar idea. What do the demand curve represent? Marginal benefits. We can really think about marginal benefits as the same as marginal utility. So as we bought more of something, what happened to the marginal benefit? The demand curve was decreasing. As I buy more of something, my marginal utility is going to be decreasing. Now my total utility is going up. As I buy more of things, I'll always be happy. But the change in that happiness or the change in my total utility is going to be going down. So if I think about kind of what this would look like in a table form, right? And I think I have my animations off a little bit, right? So these got messed up. I must have updated my PowerPoint version and didn't get right. So let's say I was kind of looking at this, right? So I've got my total utility from buying different quantities. And here I didn't do jumps of 1, I did jumps of 5. So notice, as I buy more of this good, what's happening to my total utility? It's always going up. But those first 5 units I bought, how much was my total utility changing by? 60. Now, when I went from 5 to 10, how much was my total utility? Same change in quantity, but now the change in my total utility, it's not going up by 60, it's only going up by 45. And then the next 5 I buy, it's only going up by, what, 30, et cetera, et cetera. So my marginal utility, as I buy more of this good, is going down. Total utility is always increasing, but my marginal utility is going down. Now, when we actually calculate the marginal utility represents the change in utility from 1 more unit. Here, I don't have changes in 1 unit, I'm buying 5 more. So it's almost like, think about going from 0 to 5. What was the change in my total utility? Going from 0 to 60. But if I had to get that change in utility of 60 from buying 5 more units, each unit was giving me additional utility of 60 over 5, right? Or what? I'm doing there, it'd be what? 12? Oh, right? And then I can kind of go down the list. What's the marginal utility? The next one, okay, well, going from 5 to 10, the change in total utility is 45. Divided by my change in quantity of 5, that would give me 9. Change in the quantity going from 10 to 15. Change in total utility is 30. Change in the quantity is 5. 30 over 5, 6, so on and so forth. Okay? So we've got that as we buy more of something, total utility is always going up. How do we calculate marginal utility? It's the change in total utility divided by the change in quantity. Okay? It's just like marginal benefits. We're just putting a different name to it. Okay? Any questions on this before we look at it kind of graphically instead of on a table? So if I were to plot these points out, right, and I want to look at total utility, so here's like different quantities of this good I can buy. So as I buy more of something, so what's on the y-axis here is my total utility. As I buy more of it, my total utility is always increasing. My slope is positive. But if I think about going from 0 to 1, what was the change in my total utility divided by a change in quantity? Well, here the change in quantities are nice and easy. They're 1. So you kind of see here that change in my total utility was 10. When I bought 1 more unit, my marginal utility per unit would be 10. Now, if I go from 1 to 2, that second unit I buy, the change in total utility was 5. Right? So my marginal utility would be 5. So as I buy more of something, the slope of my total utility curve is going down. What is the slope of my total utility? That's simply my marginal utility. So I'm not going to make you do this, but if I gave you an actual function for total utility, how do you find the slope? You take always amazed Kelly students to find the slope of a line, you would take a derivative. Right? Rise over run if it's linear, right? And between any 2 points, I can do that. But if I really wanted to, if I had a nice continuous line, to find that slope, I can take a derivative. Now, I'm not going to make you do that in this class, but that would be kind of the next level. Okay? So I kind of left this slide out, just maybe another way to kind of connect to this idea. If I had quantity and total utility, right? And I think the values I had were 1, 10, 2, 15. We won't do all of them. But I think it was like 3 and 18. What I could really do is think about if I were to, at all those same quantities, graph out my margin utility. Really, all I'm doing there is looking at what is the slope, right? So for that first unit, that change in my total utility divided by the change in the quantity was 10. For the second unit, that change in my total utility was 5. For that third unit, the change in total utility was 3. So what's happening to my margin utility? It's going down, right? So here's where it won't always be linear, right? We could actually see some curvature to that margin utility curve, or we'll end up calling it our indifference curve later on, okay? So my marginal utility, as I buy more of something, the marginal utility or the marginal benefit is going down. This hasn't changed from what we talked about with our demand. Just we're putting a different term to benefits. It's utility to the consumer. Okay. Any questions here before we keep moving? Okay. So, if I had completely unlimited resources, so like let's say my income, I'm Elon Musk, right? I can buy anything I want. What am I going to do to maximize my utility? Just buy everything. Anything that brings me happiness, right? Now, there might be some things I buy that don't bring me happiness, right? You know, you could argue, I don't know, maybe, you know, if my wife would love to have a pool. My grandparents had a pool, and I know that they're fun. They're an absolute nightmare to upkeep, and if there's any problems, like they just bring you more of a hassle sometimes. So for me, I wouldn't just buy that just because I want, like, the idea of owning it actually would bring me negative utility, right? But as long as something brought you positive margin utility, you would buy that if you had unlimited resources. Now the problem is we face limited resources. We only have so much income, right? So I have to start picking and choosing. So what am I going to start to buy first? Whatever, if I have a choice between thousands of goods, I'm going to buy the good that brings me the highest marginal utility. Now, the problem is I would love to have a house on the ocean, right? But why can't I buy that? Because of its price. So yes, I do want to choose things that bring me the highest level of margin utility, but I'm constrained by my budget, right? I only have a certain amount of income given the price of those goods. So what we'll start to think about is what combinations of these two goods will I buy to bring me the highest level of happiness? Well, if I didn't have any, if I had unlimited resources, I'd just buy as many as I wanted of both goods. But I'm constrained by my income and what the current prices are, right? So that's why earlier we were calling this a budget constraint, right? I'd love to have more of both these goods, but I only have a certain amount of money given the prices, okay? So what we're going to try to determine is, given our income, given the prices, where is the highest level of utility I can get to? What's the highest total utility I can get to from a combination of these two goods? Now, once again, in reality, it would be thousands. We're going to keep a simple two-good model, okay? So should I buy more of the X good or more of the Y good? Well, once again, in my thought experiment earlier, I do want to buy something that has a higher margin utility, but if those two different goods have different prices, what I really want to be making my decision based off of is what brings me the highest amount of additional utility per dollar I'm spending. So it's almost like for every dollar I spend, I want to spend it on the good that would bring me the highest level of additional utility per dollar I'm spending, right? Which is why in the real world, you know, why don't I go out and buy a Lamborghini? Well, the margin utility per dollar I'd have to spend way lower than the margin utility per dollar if I just bought, I don't know, Chevy Trax or, you know, whatever it is, because the prices are so much dramatically different that even though the margin utilities are different, the margin utility of one good might be higher, but its price might be way, way higher, right? So the margin utility per dollar is how we want to make decisions, right? So we want more utility. We want to choose whatever brings us the greatest additional or margin utility, but prices matter. So essentially, we want to choose the good that brings us the highest amount of additional utility per dollar we're spending. So what would I be looking at? My margin utility per dollar, right? How do I figure that out? Well, it's the margin utility from this good divided by the price of that good. And that gives me the margin utility per dollar I'm spending. Now, when we look at a consumer's what we call optimum, or like the equilibrium consumption for the consumer, this will always be the case, right? So let's think about why that's the case. So I'll try to give you some intuition, and then as we kind of progress throughout today and next class, I think it'll be more and more obvious. But if I am telling you that we make decisions based off of the marginal utility per dollar we're spending, let's just assume that the current combination of these two goods we're buying, the margin utility per dollar we get from good X is a little bit higher. If that's the case, what do I want to buy more of? Well, I want to buy whatever is bringing me more additional utility per dollar I'm spending. So I want to buy more of good X. Now, the problem is, shouldn't say problem, but if I buy more of good X, what happens to the marginal utility of the last unit of X I bought? We said as I buy more of something, my marginal utility is going down. So what happens? As this marginal utility starts to go down, eventually we get to a point where the margin utility of good X is equal to, per dollar, is equal to the margin utility per dollar of good Y. Right? Now, if I keep spending past this point, what would happen? Well, now the margin utility, if it goes down even more, now the margin utility per dollar is higher for good Y. So now what do I want to buy more of? Good Y. But as I buy more of good Y, what happens to the margin utility from good Y of the last unit? It goes down. So we kind of like have this back and forth until where do we no longer want to change our consumption? When I'm getting the same margin utility per dollar of both goods. Now I have no incentive to buy any more or less of either good. So it doesn't matter where we start out. I'll always want to switch my consumption towards the good that has a higher margin utility per dollar away from the other good. And as a result, because margin utility is declining, when I buy more of that good, it's going to be pushing down the margin utility. This occurs until we get those points are equal. If we ever accidentally went past that point, now there's an incentive to switch to the other good, and we'll always kind of eventually, in the long run, get to that equilibrium where our margin utility per dollar we're spending on both goods is exactly the same. We have no more incentive to buy more or less of either. We're going to have the same additional utility per dollar we're spending. Okay. Any questions on this idea? Okay. So I went through that thought experiment, or you could just remember, or you could have trusted me, although I wanted to give you some support as to why. This is going to be where our consumers optimize their spending, where the margin utility per dollar is the same. Now, this is where things can get a little bit weird, right? If I think about kind of what we call the paradox of value, total utility and marginal utility don't always correspond. But we make decisions in every model we've looked at. People and firms make decisions on the margin, right? So the idea is, if I were to buy, like, if I look at for most people, the total utility they get from a diamond, from all diamonds they buy, most people, if they own any, would own like a very small number of diamonds. So the total utility, although each unit has a high level of utility, they don't own many. Whereas water, what's the marginal utility you get from one drink of water? Really, really small. But how much water do you consume over the course of the year? A lot, right? If you think about this in terms of your life, how many diamonds do you buy over your life? Not a whole lot. Their total utility is high per diamond you buy, but you're not buying a lot of diamonds. You drink water, hopefully, every single day. So even though that margin utility per unit is really small, if the number of units you buy is high enough, that total utility is going to be really, really high. So we have kind of this paradox of value that for any one unit, the total utility of a diamond is higher. But if we look at the total utility over the course of the year, or all of those units I'm buying, the total utility of water is actually higher for almost everyone. Okay. Now that margin utility of water is small, the margin utility of the diamond is very high. We kind of get this counterintuitive result. Right? Now, what we really are focusing on is going to be this idea of the margin utility. Okay. So we won't focus too much on this, but I think it's just an interesting kind of discussion to have along the way based off what we've talked about. Okay. So the reason why this can occur is because also, how do we make decisions? Not based off of just the margin utility, but the margin utility per dollar we spend. So the margin utility of diamonds is higher. But what's also true, the price of diamonds is much higher. In fact, we can kind of think about how we might want to think about this. So let's say I have two goods, right? I've got the margin utility per dollar I'm spending on water, and I get the margin utility per dollar I'm spending on diamonds. This is an extreme example. This is just to kind of prove the point. In fact, I personally, my wife has some. I've never bought something that has a diamond in my life, right? But why? Why would I do that when the margin utility of a diamond to me is definitely higher than the margin utility of one drink of water? Well, here's just a weird one. Let's just say I could put some dollar amounts to this. And I don't know, let's say the margin utility per dollar I'm spending on diamonds is like really high, right? So if I bought one diamond, even factoring in the price, the margin utility per dollar is a lot. The extreme, though, is for most of us, if I think about going out here to a drinking fountain, what's the price of water? 0. So theoretically, even if the margin utility of water was like 0.0001, if the price is 0, anything divided by 0, and the limit is infinite, right? So why do I choose to consume water and not buy diamonds? Because it's free, right? Now, this is an extreme example to prove the point, right? There is some cost, right? There's cost in terms of it took me the time to go over to that drinking fountain. I could have been doing something else. But this is the idea. If something was completely costless to me, even if the margin utility was infinitesimally small, I'm going to consume a lot of that, right? So a little bit of an aside there, but just kind of an interesting way to start thinking about kind of how we live our everyday lives and how we make those decisions about what goods we're buying, or what combinations of these two goods we buy. Okay? So where are we at in time, and what do I want to do? So we can kind of work through some of this next class. I want to do a little bit of this. I want to save this for next class. So what I want to do is we'll work through these problems. It might even be beneficial to look through them and see if you could think about how you would solve these on your own. So if I've got marginal utilities and I also know prices and I have a certain amount of income, what good do I want to buy first? The one that has the highest margin utility per dollar. So I can almost create a different column where I take the margin utility of each good and I divide it by its price. And then I just kind of go back and forth. Which good do I want to buy? Whatever has the highest margin utility per dollar. So we'll go through these thought experiments next class, and I'm actually going to construct this, or basically take this table and put it into Excel. So I like to, it isn't the focus of this class, but I like to try to incorporate a little bit of data or kind of show you how to do things a little bit here and there, because you're going to have to work with data once you leave here if you want to be in the world of business, right? So we'll take these examples. I'll kind of throw them in Excel next class. But what I do want to kind of look at to kind of end class today is this idea of indifference curves, right? Because that discussion will go along with that very, very nicely. So if I think about, as I buy more of one good, what's going to happen? I'm getting an increase in my total utility. But to get more of one good, going all the way back to the beginning of the class, what am I going to have to do? Stop buying some of the other. So there's always going to be this trade-off where if I want to keep my total utility the same, if I buy more of one good, if my total utility or level of happiness didn't change, I would inherently have to buy less of the other good. Okay? So we're going to end up talking about these things called indifference curves. Okay? So if I've got an indifference curve, we're going to have a couple traits, right? So what this indifference curve would tell me is any combinations of these two goods, so I went back to Pepsi and pizza here, is all going to give me the same level of total utility. Right? Any 2 points on this curve. Right? So if that's the case, right, if I want to keep total utility the same, as I buy more of that y-axis good, to keep total utility the same, when I buy more of something, we said total utility always has to increase. Right? So if I'm keeping total utility the same when I buy more of one good, inherently I have to buy less of the other, right, in order to keep total utility the same. So what's going to be some traits about these curves, right? Well, here I'll kind of think about drawing this out to kind of give you a general representation. So even though I mentioned something from next class, we still have 5 minutes. I'm going to go through a little bit of stuff, okay? So I saw a bunch of people pack up. This is where, it's still good to pay attention here, right? Because I'm not going to revisit these topics next class. So let's say I had any two goods, and I'm telling you that an indifference curve represents the total utility I'm getting from these different combinations of these two goods. But it's always the same. So if I could put a value to it, I'm getting 100 units of happiness from all of these different combinations of these two goods. So why do higher indifference curves, and luckily this is an intuitive result, why do they result in higher levels of total utility? Well, because if I have the same amount of good X, if I'm on this higher indifference curve, if I have the same amount of good X, however, the amount of good Y is going up, what has to be happening to my total utility? I've got the same amount of one good, more of the other. Am I going to be happier or less happy than before? If I have the same of one good, more of another, I'm going to be happy or have a higher level of total utility. So one thing that we'll also say is these curves can't cross, right? So let's think about why. Okay? So if I have these two goods, let's say here's my original indifference curve, and the total level of utility I'm getting is 100. We somehow can put a value to it, right? If I was thinking about if these curves crossed, right? So let's say I'm like, oh yeah, this is a lower indifference curve here. That makes sense because I have the same amount of good X, but I have less of good Y. So if I have the same amount of X, but less of good Y, my total utility should be lower than before. However, this can't occur. They can't cross because if that was true, what would be true about points over here? At the same quantity of X, if I had more of the y-axis good, what should be true about my second indifference curve over here? It should represent a higher level of total utility, not a lower level. So that's why they can never cross, because then we would have kind of conflicting results depending on what kind of point we're looking at. So it has to be that higher indifference curves represent higher amounts of total utility, and those indifference curves can never cross. Okay? Any questions on this? And I'm going to lead us into next class with one more thing, which is if I'm thinking about these indifference curves, they represent a total amount of utility that I'm getting. So what's the total amount of utility I'm getting from both goods? The margin utility I'm getting from good X times the quantity of good X times the margin utility I'm getting per unit of good Y times the number of units of good Y I'm buying, right? So it's, if I buy 20 units of good X, and each one is bringing me a total additional utility of 2. The total utility I'm getting from good X is the quantity I'm buying times the margin utility. Okay. So if I rearrange this, right? So I do a little bit of algebra here. I subtract this from both sides, right? I'd end up with the margin utility of Y times the quantity of good Y is total utility minus the margin utility of X times the quantity of good X. If I then divide both sides by the margin utility of good Y, what I'm going to end up with is my Y-axis as a function. So here, this is going to be my intercept. And then here, I have the margin utility of X over the margin utility of Y times the quantity of good X. Oh, this is basically the function for my indifference curve. So notice, what is the slope of my indifference curve? It's always going to be not the relative prices, but the relative marginal utilities. So we're going to use this next class. I'll kind of run through that Excel example. We'll then combine our indifference curves with our budget constraints and think about how people make optimal decisions, income, price effects that we'll talk about, differentiating those. Other than that, I will see you guys office hours as usual tomorrow, and I'll see you guys on Thursday.